great. Okay, thank you very much. And unfortunately, we failed that interview. But we are employed in one of the shop managers. And after collecting a bunch of data for days, we find out that the net profits per hour relies on these three decision variables: the amount of pizza, the amount of machine, and the amount of staffs. I'm sorry, pizza machine, staffs, and customers, following the coming function with this constraint. Here because today we focus on how we solve this equation, but in the math modeling, this equation comes from your data. So I recall that I think the problem B, maybe in 2021 MCM, the question gave us like it's talking about the bees, like some different kind of bees, and it also gave us the data sheet. And for that question, we need to first like how data analysis did. So first collecting the data and do some cleaning operation on our data, and then plot the graph, and then get the fitting functions, and just figure out how the relation is amongst the decision variables. So, but for today, we just focus on this. So this is given now, and we figure out that the net profit is relies on the pizza machine, staffs, and customers. And the X1 here is the amount of pizza machine, X2 is the amount of customers, and X3 is the amount of staffs. And now, first, I have a question for you guys. What's the meaning of linear again? So,
highest degree 1.
Yeah, right. The power should be 1. That's like the simple meaning on the linear. However, we have 2, 2, -1. So and that is called nonlinear. So in this case, how should we deal with? So usually when we have this first, what's the name for the y again? Yeah, right, objective function. And yeah, right. And in the x2, x3 are the decision variables. So first, when we deal with the objective function, we need to convert it to what? Sorry.
Oh, yes, we did convert it.
Yeah, how about this? Why do we need to convert our y?
Oh, I think that you put like negative, just because MATLAB only accepts minimum and negative ones.
Right. Yes, every step we made is out of reason, because we are going to use MATLAB to get the solution, and there are some limitation on MATLAB, and MATLAB always can find the minimum value on a function, and that's the reason why it's a little pity that I cannot use my iPad. So because I'm about to like have this space to let you guys fill out, but it's okay. You guys can say it. So first we need to convert our y to negative y. So which is negative x1 squared minus x2 squared minus 5 times x3 to the -1 minus 10. How about the constraint? So what's the second limitation of the MATLAB?
You have to switch everything to minimum.
Yeah, the sign on our inequalities or equalities should be either less or equals to. So we need to convert our first inequalities to times -1 for the both sides.
so that we can change our sign over there. And we don't have to do anything on the second one, nothing to do with the third one, the same. And for the last one here, actually, if every time if we have this is called lower bound and upper bound. So this is called lower bound. If you lower bound means like minimum value. So in our MATLAB, we also have another format to plug the to code the function. So here, if we have lower bound, we can take this as a lower bound. We don't have to take this in inequalities, but basically they are equivalent. So, and also here's the format in MATLAB. So we input our X, we will get our Y back. And this is, what's the academic words for this? What function? Invoking function. Because we are going to invoke this function, and this function is made inside the MATLAB. And what kind of elements do this invoking function have? We need the f0. F sub 0 here is, oh, sorry, I forgot to, okay, this notation here is wrong. I forgot to change this one. Oh, because I just copied down from the last week and I forgot to change it. Okay, this one will be a little bit different from the format we have in the linear programming. So f sub 0 here is just objective function. We don't have to do any change on our objective function in the nonlinear programming. And but I think the rest of them are correct. Yes. So A is the max. Oh, in this case, since we don't have inequalities and sorry, we don't have linear inequalities or linear equalities. So A B here, A B A equalities. And B equalities, we don't have them. And but we do have LB and we don't have UB. And the F1 here means the nonlinear constraint, included the inequalities and equalities. And here's a very important note in writing code in MATLAB. If there's no one of the elements, we have to use brackets to replace it. Like taking that position. Yeah, so and here, so we need to translate the math language to the MATLAB language. So our objective function will be translated as, so here function f equals to I call it function 0x. So so this if you learn Java, it is like if we wanna determine an integer, for example, maybe I equals to 10, so we have to create the int I equals to 10, and similar idea here. So if we wanna have a function, we have to have the keywords function. Function f equals to the names over here is up to you. You can call whatever you want. And I call it function 0 sub x. The x is the input, and this is the name. I can invoke this. And the step over here feels like we join a shape. So let's say if I wanna draw a selfie on you, yeah. So first I need to draw the shape of you, right? And then next, I'm gonna fill out all your details, like you have a big eyes, you have a sexy brown eyebrows, right? And so that's why I did here. F equals to negative x1 squared minus x2 squared minus 5 times x3 to the negative 1 minus 10. So this feels like filling out all the details for me. And For the nonlinear constraints, we have I can show you in MATLAB. So or maybe I can just zoom out. Zoom in. Probably it is better to see like this way. Yeah. So here, so we have same idea. So this is the keywords function. We have to type that. And this is GH. G here refers to nonlinear inequalities. And the H here refers to nonlinear equalities. And also we can give it a name. I call it function 1. And the input should be X. And G equals to this equation actually is this one with times -1 because we need to change the sign over here. So that's why we have negative x1 squared minus 4 times x2 plus 2 times x3. And if we want to, every time if we want to type another equation, we have to enter. We have to shift another row. And so after I type this, I just enter. So I got here. And I type my second equation, which is okay, this should be, I think this should be 24, my bad, yeah. So we by the way, we also need to times -1 for the both sides. So we have this. And if these are all the nonlinear inequalities, we need to end them, we need to close them with the bracket. And so after I type that, so I enter to another row. So I just type similar ideas. I type H equals to that. But here, what you need to care about is, let's say, this equation. We need to move this 15 from the right to the left. Every equation we type should have 0 on the right, only 0. So far so good. Okay. Yeah, sure.
How can I for example, the first one is bigger than 0,
Yeah, right.
and the second is less than 20 is less than 0. So how can I make
We also need to remove this 24 from the right to the left. Yeah, and that's why, yeah, that it should be 24 over here.
okay.
Yeah, that's my bad. I don't know why I typed 25 there. So yeah.
So for all the nonlinear inequalities, you zero it out by moving
Oh.
to the other side.
I'm sorry. I'm so sorry for the people in the Zoom. I guess I forgot to share screen, and they yeah. Okay, my bad. Okay. Yeah. Okay. I'm so sorry, Yutong. So sorry. Yeah. But later I will upload the materials in the Discord. So. Yeah. So yeah. Sorry.
Yes,
What's your question?
I think you did, because I'm looking at it, it seems like that's what you did.
Yeah, and for the last one, since we have a more convenient format in nonlinear programming, so we can take this as our lower bound. So and so here this is the implement, and well, I actually have a very interesting story on this implement. Just right happens this morning, because I tried to run my codes but failed, and I think I spent like maybe like an hour and a half to figure out the bugs, and only to find out that I make a very very stupid mistake that I shouldn't make. And okay. So by the way, you can access the online version without paying anything. So and here, so similarly in Java, if we like usually when you code the entire programs, you might have more than one solution. So it is a good behavior for you to write down your function into another new file. And so this is my, so here, this is my, I call it main window. This is my main window. And so first, I need to create my function in a new file. So here, this is our objective function. And can I zoom in? Yeah. So every time we write a function, we have to type n. It's just a format. So this is how the objective function looks like in MATLAB. And this is our nonlinear function, nonlinear constraint in MATLAB. This is exactly the same what I just shown on my PDF. And here, so this is my the invoking function. So I input my x, then I will get the y back. Since the y is the minimum, yeah, so at the end we need to flip it again. So we type invoking function, and here, so if we wanna invoke the function that is not inside your files, you need to like use this mark over there, the code with single one. So we type that, and this is the name of the function 0. So here you see, as you can see, this is, oh, this is the initial value. The initial value in this case is not given. However, it doesn't, it won't do anything change on our max on the y value here, because later I will show you why. And here, there's no this constraint, so we just use brackets to replace them. And here is the lower bound. There's no higher bound, and this is the non-linear constraint function. Yep.
So we need to remember the order, because the invoke function is the order is first one is blah blah, and the second one is blah blah.
Yeah, right. So every time you type this, you have to remember this.
Okay.
You have to stick with this order. You cannot change.
Okay.
Yeah. And so here I will demonstrate. Let's run. So as you can see, the value for the solution for x here is 0.1477, 7.59, 8.65. And the y we get back is 68.29. And if we take a look on the command window, we will see that, oh, what's going on here? There are a bunch of G and H, right? And it's very long, right? Okay, if I change my initial value, let's say I'm going to write it like 10,000, 50, and maybe 900. So if you want, every time if you wanna like clear your command window, you just type CLC, and they are gone. And this time I'm gonna run again. As you can see, it's longer. Why? So this is how the computers works. The initial value. So if we can imagine that now here's a box, and I put a sweet candle, like a candy, in like some position on this box, and I let an ant to figure out to find the sweet candy. The initial value here feels like I place for example if the initial value is 000, and if we place this box at the original point, so it seems that I put this ant at the original point at the beginning. So if I change it to 10,000, 50, and 900, that will give me a point, right? So if we in the XYZ system, right? XYZ, so that gives me a point in this system. It feels like I put this ant on that point at the beginning, and I let it find the candy by itself. So if we can, so in this program, it won't like really affect too much because the time we get is close, right? For these two different initial values. But if we are dealing with like a huge bunch of data, the initial value you choose is important in that case, because that will foster your programming. Because sometimes some solution you might need to wait for like half of a day to get it. And yeah, so yeah. So any question on the initial value?
So the initial value is for example, if you put a 000 with it became from 000 and 5.
Yeah, right. So that's how the computer works.
Oh.
And yeah, and
So if you put a 1,000, you maybe close to the exact value, you will be
right, you will be faster, right? Yeah, that's how the initial value works. And it won't change anything on your minimum y there. Why? Because your minimum value of the y does not rely on whichever point you start with. Make sense?
Is that the same minimum value that I output you at the bottom
Oh.
left there?
Okay. I think probably it is because my initial value messed up. I think probably I messed up some. Oh right. Oh wait. Good catch. Wait. How come? Okay. How come I got a different y here? Huh. I think probably maybe it's the constraint stuff. Okay. How about let's run it again. That's 28 something. But if I change to 0, 0, 0, and that will give me, oh yeah. I think probably because we have constraint over there. I think probably the initial value I choose is out of the constraint, because we have in 1,000, 50, and 900, right? And recall that the constraint, obviously, the second one won't follow, right? Yeah, yeah, good catch. Yeah. Well, it refers, it means that you are paying attention to the lecture, and I have picked to that. Yeah. Yeah, right. You're right. Yeah. So, and you actually throw a good point. The initial value cannot be chosen by whichever we want. So I have to correct my sentence before. Yeah, right. Thank you very much. Yes. So the initial value should still stick with your constraint. Yeah. And right. See, we cannot always trust the computers. Even though the mistake it makes is based on mine, but yeah. And yeah, and this is how we get the solution for this nonlinear programming. So do you guys have any question? Good. Easy, right? Yeah, so as you can tell, in the math modeling, the programming part is not the most difficult one. Like, for example, how do you come up with those constraints? As I said before, those based on your techniques on cleaning your data. By the way, we have different types problems in math modeling competition. If you're not really good at like dealing with data, you can avoid that one and you can choose another one. And yeah, and also like, for example, how do you come up with the models? And in the future, I also will show you like how, because as you can see for the linear programming, it's still not quite satisfying. Why? Because you will see in the future some question it's not a good reason to choose this one, even though so far we only learned 2 modules, right? Linear programming and non-linear programming. And obviously I haven't met any problems that can be used linear programming because the limitation on that is obviously. So but even though for the non-linear one, is not powerful in real life. Yeah. So, and yeah. And I think this is the section that I want to cover for today, non-linear programming. And people in the Zoom, do you have any question?
No.
Oh, I think I unmute. Oh no, I unmute all the time. Oh God. Oh, oh, okay.
I'm surprised nobody said anything.
Oh, okay. Maybe I just unmute my. Maybe I just mute my speaker. Hold on. How can I activate my speaker?
Otherwise, somebody will see what this is.
Yeah, I think. Yeah, I think I'm good, but I couldn't hear anything from people in the Zoom. Maybe they have question. Yeah, I mean, if you have question, you can just type. But I don't know for somewhat reason I couldn't active my speaker. Well, oh, probably I am recording now. Well, yeah. Sorry, I'm a new speaker, so I mess up. Yeah. So yeah, that's it. So yeah, and right. So I might stop recording and.
So we will learn how to create this construct in the future.
Yeah, for sure. And as we go deeper and deeper, we will touch more higher and higher algorithm from the math modeling. Like for example, the logic behind this invoking function here is something related to okay, I might need to check the words.
It's the setting for me. I think that's setting up the inequality, setting up the objective. I think I have a hard time.
Yeah, something like projective
I
programming.
think the programming between should be a problem. It's setting up the equation.
Yeah,
I think that would be like the way to do this.
yeah. Maybe the programming is just a tool. It's just
Yeah.
a calculation.